When we first saw them, they looked like just another wonder of digital art or graphic design, something you could repost to support the artist. Except in this case, the artist is the universe. The Webb telescope's first images have gone rightfully viral, but are they not actually as real as NASA's telling us? Keep watching to find out what kind of editing is behind the deepest images of our universe in history. First up, what's so special about these images? In case you're one of the people who missed out on one of the most incredible astronomical advancements of all time, we just got the first set of pictures from NASA's James Webb Space Telescope. The 5 pictures show the universe in more detail than we've ever seen it before, and they're all mind-blowing. The most popular image is of the galactic cluster SMACS 0723, where you can see hundreds of smudges of light in different colors. Each smudge is a galaxy of its own, and some are as far as 13.1 billion light-years. For context, 1 light-year is about 6 trillion miles. This also means they're looking into the past, as the light we're seeing in the images took around 13 billion years to reach us. The red galaxies are much older ones, and we're seeing them as they were right after the Big Bang. Next time you feel like your problems are a big deal, just think about the fact that those hundreds of galaxies all exist in a patch of sky that would be covered by a grain of sand held at arm's length. The Disney movie-esque Carina Nebula was seen in insane detail, showing thousands of new stars forming out of dust and gas clouds. Another nebula is the Southern Ring, which shows 2 dying stars orbiting each other about 2,500 light-years from Earth. Stephen's Quintet, first seen in 1877, also got its best on-camera moment yet, sparkling from 290 million light-years away, and thousands of undiscovered galaxies showed up in the background, which astronomers are calling photobombers. And lastly, we got a picture that wasn't as cool as the others, seeing how it wasn't really a picture at all. It was a graph analyzing the atmosphere of WASP 96b, a planet that's around 1,150 light-years from Earth. We haven't found any life yet, but the graph does show a lot of water, which means we can't rule it out just yet. So how did we get those pictures? All the images we've seen so far have been collected and compiled over hours. It's not as simple as holding up your phone and snapping a picture. In particular, SMACS 0723 took 12 hours to collect, as opposed to a similar Hubble image that took weeks to get. Then again, the Hubble mirror was only 2.4 meters. This comes from the Webb telescope 6.5 meter gold-plated mirror, made up of 18 hexagons made of beryllium. Why beryllium? Is much lighter than other reflective materials like aluminum or glass. Why gold? Well, when you put $10 billion into a telescope, you can afford to plate it in gold. The mirror is built to spin out and collect radiation coming from celestial bodies billions of light years away, which means the mirrors had to be perfectly smooth, and with the images we can see now, it worked. But the real question is, did NASA fake it? You've sent up the telescope you spent 25 years building. You've got the images, but NASA still manipulated them before we got to see them. Does that mean they photoshopped in a couple of extra stars? Did they make it more impressive to look at? Are the images even real? As we mentioned earlier, there is no Snapchat story picture. The telescope didn't hold up a camera, get a quick picture, and send it right back to NASA for them to show us. First off, most of these images contain the kind of light humans can't see, including infrared and ultraviolet. So when the actual Webb images first showed up, they don't look like the stunning ones you saw on your Twitter timeline. They don't actually look like anything, unless you're an astronomer who knows what to look for. When the telescope finally reached space, it was 11 years behind schedule, so scientists couldn't plan the images until they could see something. Finally, they selected the shots with the highest priority targets, and ones that would look best in a picture. The raw data is sent back to engineers on Earth using NASA's Deep Space Network and collected at 3 complexes in California, Madrid, and Canberra. After that, it's time for processing. Here's where you might say the images are fake. The colors in the images aren't actually real, but it's not just a filter to make it look pretty. The colorizing is necessary to actually be able to see anything. The telescope can only see in infrared light, which humans can't. Infrared light is essentially just a fancy way of saying heat radiation, which is out of the range of visible to humans. Imagine a rainbow. You can see from violet to red, but not beyond that. Infrared is what lies beyond red. The telescope does use filters, which allows it to detect fainter light compared to brighter sources, but none of it is actually in color. So how did we get those multicolored, sparkly pictures? The Webb images are moved from the infrared part of the spectrum to the visible part, and the way it's done is pretty interesting. Narrow band filters are then used to detect different wavelengths of light, and each different wavelength is assigned its own color. This is also done according to the rainbow spectrum of visible light, with the longest wavelengths getting red and decreasing wavelengths getting orange, yellow, green, and so on to blue, which is the shortest. The engineers can now create a composite image, which is what we saw in the first 5 Webb pictures. So no, nothing about these pictures is fake. The engineers only took the image we couldn't see and shifted it into something we could. It's the same as colorizing an old black and white photo. The picture is the same, only with color applied onto it. The process isn't quick and easy either. Turning raw data with a bunch of heat radiation information into spectacular, colorful images can take anywhere from weeks to a month, and this is only the beginning. Come September 2022, we're going to see more images from an area that Hubble previously covered, in way more detail and an exposure 10 times longer, bringing us closer to the creation of the universe we live in. Now for what else is happening in the sky. The Webb telescope technology revolutionized healthcare. How can a telescope meant to look at stars and galaxies affect the healthcare sector? It turns out it's pretty useful, because one of the technical aspects just made diagnosis and eye surgery a lot easier. The 18-hexagon mirror we mentioned took years to make. The tiniest bump could ruin the image quality completely, which means the mirror had to be extra smooth. This meant plenty of measuring and polishing, making sure we got completely unobstructed images. To ensure the smoothness of the mirrors, a special sensor was developed to check for imperfections that were thinner than a human hair. Now, that sensor is being used somewhere very different, specifically the human eye. The sensor can be used to check for irregularities in the surface of the eye, allowing for almost instant diagnosis of eye-related issues. While such tiny bumps and ridges might have taken a much longer time to detect before, the sensor allows us to see them instantly. This same technology can also be applied to other aspects of healthcare, such as the detection of swelling in blood vessels. Next, the telescope had some rough luck. When you're a telescope up in space, millions of miles away from any humans who can fix issues, it's almost guaranteed that you're going to get hit by some of the stuff that's floating around up there. The James Webb Telescope might be a wonder of science and technology, but like everything else, is no match for nature and chance. The painstakingly smoothed and perfected mirror seems to have been hit by micrometeoroids, each about the size of a grain of sand. Unfortunately, even that had the ability to cause some serious damage, and NASA reported 6 deformations on the mirror. For the most part, these can be fixed by just changing up the math that NASA uses, but one of the 6 strikes has caused significant, uncorrectable change. While we don't know how exactly it will impact anything, NASA does say that it won't mess up the data too much. However, it's definitely less accurate than before. Hopefully, the upcoming images won't be any less pretty. And lastly, we just heard a heartbeat. Astronomers are having the time of their lives with all the new discoveries these days, because a radio signal has just been detected from a far-off neutron star, or so we think. The pattern is the clearest and most regular to date, which is why it's being called a heartbeat, but we don't actually know where it's coming from. But as we continue to develop technology at this rate, we might just be one step closer to unlocking the universe's deepest secrets. That's a wrap for this video. What did you think of the images? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.